Hi, good afternoon, everyone. I hope all of you have gone ahead and done the assignment that was given on functions. I will also be sharing the recorded video solutions of functions shortly. For now, I have uploaded one more assignment on the set theory, the first topic that we covered, and that is along with the video solution. So just go through that. There are two assignments that you have to cover in set theory, and then the assignments on functions. And today I am going to go ahead and I'm going to start with limit, continuity, and differentiation or derivatives. I wanted to cover integration also, but I will be taking integration separately in another lecture. But for now, we will be focusing on limit, continuity, and differentiation in this lecture. Let's start with it. सबसे पहले हम बात करेंगे लिमिट की. Now, what is limit? Limit होती क्या है? Whenever we talk about limit, actually, it is simply the value that the function takes at a particular x. Now, the only difference that happens in limit, क्यों हम उसको limit बोलते हैं? Because we don't assume at x. We ask ourselves what happens when the function approaches x. मतलब, if I go ahead and I give you a particular, I just make this as a particular function. ये मेरा curve है function का. And I take a particular value of x. Say I take, okay, x is 1, and when x is 1, the value of the function is this. This is given by f1. Matlab, the value of the function when x is 1. Now the question here is, ki what happens when I am approaching 1? I am not at 1, but I am trying to approach 1. I am going towards 1. Then how my function acts? That is called as limit of the function. So the limit of the function is how your function will act. कैसे आपका function चलेगा जब आप एक particular value को approach करोगे. जब आप यहाँ से और यहाँ से एक particular x को approach करोगे तो आपका function क्या value लेगा? What value your function will be taking? That is the concept of limit. ठीक है बेटा? So see here, graphically देखो. fx is a function which is defined between -6 to 11, right? The limits are defined as the values the function approaches as it goes to an x value. तो जब हम x को approach कर रहे हैं, when we are approaching x, what is the value your function will take? That is the concept of limit. ठीक है? Continuity क्या है? In the most simple terms, when we talk about continuity, तो जब basically when we start teaching a layman कि continuity होती क्या है, so we go ahead and we say that look, I am starting by making a diagram. मैं एक diagram बनाना शुरू कर रही हूँ. If I don't have to go ahead and lift my pen, मतलब मैं यहाँ से बनाना शुरू किया, I'm making, so just see here. I am going ahead and I am making a diagram. If I have to lift my pen and then draw, then it is discontinuous. But if I am making a diagram and I don't have to lift my pen, then it is continuous. So if you have to lift your pen in between, अगर आपको 1 मिनट के लिए पेन उठा के बनाना पड़े, that means that at that point there might have been some discontinuity. But if you don't have to lift your pen और एक साथ आप बना पा रहे हो, that means that this is a continuous function. It's a continuous function. So look here, this is the basic definition of continuity. It says loosely defined as the ability to draw a graph without you lifting your pencil. अगर मुझे पेन ना उठाना पड़े, if I don't have to lift up my pen, then though it's a continuous diagram. But if I have to lift, जैसे यहाँ, I plotted here, then I had to draw a dot, I had to lift back and then I draw. Then I had to again lift my pen, draw from here. I had to lift, draw. अगर ऐसा कुछ करना पड़े, wherever you have to lift your pen up, that is called a discontinuous diagram. उसको हमें discontinuous diagram बोलते हैं. Now, when we talk about continuity and discontinuity, there are various types of discontinuity that we have in maths. The first type of discontinuity is called a removable discontinuity. Removable discontinuity, as the word suggests, it is that discontinuity which can be removed. तो अगर हम एक फंक्शन की डिसकंटिन्यूटी को रिमूव कर सकते हैं, जैसे सी हियर बच्चे, I am saying that the function is approaching a particular value. So then at -3, the function value is not known to us. I have drawn a circle and then again the function is defined, right? Then such discontinuities can be removed and this is called as removable discontinuity. इसका एक बहुत अच्छा एग्जाम्पल लेकर देखते हैं. So I will take this later on. अभी तो हम थोड़ा graphical analysis कर रहे हैं, but just see here. Suppose I tell you that your function is x square minus 9 upon x minus 3. And I ask you, okay, what happens when your function approaches 3? क्या होगा अगर function की value हम x equal to 3 पे evaluate करें? This may seem very easy that if I just put 3 square minus 9 upon 3 minus 3, this is giving me 0 by 0 form. And therefore you may think ki, okay, this is a discontinuous function, right? This is a discontinuous function क्योंकि एक 0 by 0 form आ रहा है. There is another way to see this thing. It may clearly seem to you that the denominator, when you put x equal to 3, जब हम यहाँ पे 3 डालते हैं, the denominator gives me 0, right? And अगर denominator में ही 0 आ रहा है, it means that I am not able to define my limit at that point. But I know that there is a formula which says that a square minus b square is equal to a minus b into a plus b. ये a square minus b square का formula है, right बेटा? a minus b into a plus b. So on that basis, I can write this as x minus 3 into x plus 3. तो x square minus 9 आ जाएगा, divided by x minus 3. And clearly I can cancel this out. And बच्चे, what will I get? I will get the answer as x plus 3. और अब जब मैं evaluate करूंगी at x equal to 3, only x plus 3, I will get the answer as 3 plus 3 equal to 6. So I have been able to remove that discontinuity. Discontinuity थी तो at x equal to 3, the original function is not defined. ये function defined नहीं है. But if I just go around and simplify the function, I am able to get you a value at x equal to 3 कि function का जो value होगा वो 6 होगा. This is a way of saying that this is a removable discontinuity. ठीक है, we will talk about it when I do the numerical also. But the other one is called as jump discontinuity. Jump मतलब at that point ना आपका function एक jump ले रहा है. जैसे for example, come back to this diagram and see what happens when I talk about x equal to 0. जब हम x equal to 0 की बात करते हैं, this is 0. हाँ, जब हम 0 को लेफ्ट हैंड साइड से अप्रोच कर रहे हैं, when I am going towards 0 from the left hand side, I am going towards 0, 0, 0, 0, 0. But when we are going towards this 0 from the right hand side, तो मेरा function value ले रहा है 3. So when I am going towards the function from the left hand side, my function value is also going towards 0. जब मैं x को 0 से approach कर रही हूँ, the function value is going towards 0. और जब मैं function को right side से approach कर रही हूँ, when I'm trying to approach 0 from here, my function is going towards 3. So I am taking a jump in the value ना, that at x equal to 0, जैसे ही x 0 हुआ, you see that the colored dot is here, It means that at f equal to 0, value of the function is actually 3. ये open dot है बेटा. मतलब value is not 0. Function का value 3 हो जाता है. But when you approach it from the left hand side, जब आप यहां से approach करने की कोशिश कर रहे हो, it is going towards 0. So it is going close to 0. But जैसे ही 0 हुआ function का x का value, the function takes the value 3. So we can go ahead and say that this represents a jump discontinuity. ये jump discontinuity हो गई. Now the third part that we have, beta, that is called as another way to show removable discontinuity. That is happening again at x equal to 2. तो अगर हम यहाँ देखते हैं फिर से the third part of this diagram, again you see that from both the side I am going towards the same value only. Whether I approach 2 from this side or I approach 2 from this side, I am going towards the same. मैं एक ही point पे जा रही हूँ. But at x equal to 2, the value of the function is this. सिर्फ f x equal to 2 पर यहाँ पर function का value अलग है. But otherwise I am approaching the same value. So there is a way to remove this discontinuity, and it is a removable discontinuity because actually you are going towards the same part of the function. In a way, it seems to be continuous function. Then another kind of discontinuity that we have here, this is known as infinite discontinuity. Infinite discontinuity कब होती है बच्चे? When you are approaching infinity. अब यहां देखो, this function at x equal to 6, जब हम 6 पे हैं, there is an asymptote. इसको बोल देते हैं asymptote. This is called as asymptote. Asymptote means at x equal to 6, मैं function define नहीं कर पा रही हूँ. I am not able to define the function. It is just a dotted line representing कि शायद वो infinity या minus infinity पे value होगी. I am not able to define the function at x equal to 6. But try to see that when I am going close to 6 from the right hand side, जब मैं यहाँ से 6 की तरफ जाती हूँ, when I am going towards 6, the function is going towards minus infinity. And when I am going towards 6 from this side, then also the function is going towards minus infinity. So when you are approaching some infinity value, that is called as infinite discontinuity. Up. We need to also understand what is the one-sided limit. So one-sided limit, we have two parts in it, beta. एक को बोल देते हैं हम left hand limit, and the other is known as right hand limit. Right, beta. Left hand limit means you are approaching the function from the left hand side. So I am, so जैसे यहाँ पर, from here, if I am approaching the function from the left hand side, then it is left hand limit. If I am approaching it from the right hand side, then it is right hand. So left hand limit is when you approach the function from the left hand side, and right hand limit is when you approach the function from the right side. अब थोड़ा सा इसमें एक बारी mathematically समझो. See that suppose बच्चे I have taken some values of x. जैसे यहाँ पर value of x है 0, 1, 2, 3, 4, 5 and so on. Now I want to ask myself, what happens when you are at x equal to 3? हमें evaluate करनी है limit at x equal to 3. What will I do? I will go towards 3 from the left hand side and towards 3 from the right hand side. तो जब हम 3 की तरफ left hand side से जाते हैं ना, it means I will take some values of 3 which are less than 3. जैसे let me explain this through a function. Let's say my function is y is equal to x plus 2. Right? You just plot this function. क्या function बन के आएगा? कैसे बनेगा? When x is 0, y will be 2. When x is 1, y will be 3. When x is 2, y will be 4. When x is 3, y will be 5. तो आपका जो फंक्शन का डायग्राम बनेगा ना, it will be like this. This is your function y is equal to x plus 3. This is your function. अब समझो. I know when I will plug 3, जब मैं 3 प्लग करती हूँ फंक्शन में, the answer I will be getting will be 6. मेरे को 6 आंसर मिल जाएगा. I will get the answer as 6. Now, I have to go ahead and approach this function from the left hand side. तो मैं बोल रही हूँ what happens when I will put values less than 3 but very close to 3. तो maybe I can start by putting x equal to बहुत close to 3 करना है, but 3 minus represents that it should be less than 3. So okay, let me start by putting 2.9. क्या आंसर मिलेगा बच्चे? Y is equal to 2. Sorry, this will be 5 na. 3 plus 2, 5. I just wrote 6. What will I get when I put 2.9? I will get 2.9 plus 2. That means I will get 4.9. So when I'm putting a value very very close to 3, जैसे मैंने 2.9 plug in किया, तो मेरा आंसर आ रहा है 4.9. So when I just plug 2.9, I am getting the answer as 4.9. Next, what I can do? Let me just plug something again close enough to 3. ठीक है जी. Let me put 2.99. तो क्या आंसर आ जाएगा y का? It would be 2.99 plus 2. That means 4.99. So I am going more and more close to the value of 5. That means as I am approaching 3, जैसे जैसे मैं 3 की तरफ बढ़ती जा रही हूं, मैं यहां से 5 की तरफ बढ़ती जा रही हूं, the value of the function at 3. So as my x is going close to 3, जैसे x का वैल्यू 2.9 हुआ, फिर 2.99 हुआ, फिर 2.999 हुआ, as my x is going close to 3, the value of my function is going close to f of 3. Then this is called your left hand limit. Ab beta right hand limit, what is that? Limit x going to 3 plus. मतलब again I have to approach 3 only, but I have to take values greater than 3. ठीक है जी. Let's take the value that my x will be 5.01. So what? Sorry, 3.01. So what will be the value of my function? X plus 2. So 3.01 plus 2. So 5.01. Then मैं थोड़ा और 3 के पास जाती हूँ. So let the value of the function be 3.001. So what will be the value of y? It will be x plus 2, 3.001 plus 2. So बच्चे, this will be 5.001. Again I am going close to 5. जब x का value मैंने 3.01 लिया, it was 5.01. जब मैंने और 3 के पास लिया, it became more close to 5. So again, as I am approaching the value of x from the right hand side, taking values greater than 3, again I am seeing that I am approaching the value of the function, right? So when you approach the function from the right hand side, जब आप इस direction से function की तरफ जाते हो, that is called as limit x plus, right? जैसे यहाँ पे 3 plus हो जाएगा. So this will represent limit x tends to 3 plus. Now, what is continuity? हम continuity को कैसे define कर सकते हैं? So I can say that when I am approaching the function from the left hand side and when I am approaching the function from the right hand side and it is equal to the value of the function. यहां से धीरे धीरे जैसे जैसे हम 3 की तरफ जा रहे थे, as we were going close to 3, I was going close to 5. यहां से जैसे जैसे हम 3 की तरफ जा रहे थे, as I was going close to 3, I was going close enough to 5. And the value of the function at 3 was also 5, right? It was equal to the value of the function. Beta, if this condition is satisfied, then we say that the function is a continuous फंक्शन, माने मेरा फंक्शन एक कंटिन्यूअस फंक्शन है, right? So this is what the one side limit means. One side limit means you are trying to approach your function from two different sides. एक बारी left side से approach करो, एक बारी right side से. Is that equal to the value of the function? Yes. अगर है, then the limit of the function will exist and the function will be continuous. Now, this is the definition. All of you will mark this in your notes. So when we approach limit x to a plus fx, this is equal to limit x going to a minus fx. This is equal to the value of the function at a. तब हम इसको बोल देते हैं that it is a continuous function. अब क्वेश्चन जो एग्जाम में आता है, what comes in exam? The first important thing that will come in exam is when does a limit not exist? ऐसा कब होगा कि लिमिट एग्जिस्ट नहीं करेगी? So the first thing, if when you are approaching the function from left hand side and when you are approaching the function from right hand side, if these two values are not equal, अगर ये दो values equal नहीं है, then the limit will not exist. जैसे हमने इस ग्राफ में देखा था. Just try to see this graph. When I am going from left hand side, this is x is 1, the value of the function is minus 1. When I am going from right hand side, then I am going towards 2. So I am not going to the same value, na? When I am approaching it from left hand side, अलग आंसर आ रहा है. When I am approaching it from right hand side, अलग आंसर आ रहा है. So when you get different answer, when you approach from left and right hand side, then the limit does not exist. ये हमारा first point हो गया. Second point, a general limit does not exist whenever function increases or decreases indefinitely or infinitely. बेटा अगर फंक्शन इंक्रीज ही हुए जा रहा है, राइट, एंड देयर इज नो बाउंड टू द फंक्शन, राइट, जैसे यहां पर हमने देखा था दैट दिस वाज x इक्वल टू 6 और ये फंक्शन डिक्रीज ही हो जा रहा था. इट वाज नॉट गोइंग टुवर्ड्स एनी वैल्यू, इट वाज कंटिन्यूअसली डिक्रीजिंग. सो इफ दैट इज द केस कि फंक्शन कंटिन्यूअसली इंक्रीज या डिक्रीज किए जा रहा है, in that case also we say that the limit does not exist. A limit does not exist in case of infinite oscillations while approaching a fixed point. Again, हमने ये oscillations दिखा दिए हैं. So if there are oscillations in the function, then also the limit will not exist. Okay बेटा, अब कुछ rules है limit के. So for example, the first is called the sum rule. Sum rule क्या बोलता है? That if I want to go ahead and I want to find the limit of the sum of the functions, then it is equal to limit of the first function and limit of the second function. Take an example बेटा. जैसे मैं बोल दूं आपको find limit x goes to 2 x square plus 5x. मतलब यहाँ दो फंक्शन है, एक है x square, एक है 5x, and I need to go and approach to 2. So what will I do? I will say simply this is x square पे लिमिट डाल दो and put limit on 5x. So this will be 2 square plus 5 into 2. This will be 4 plus 10. This will be 14. So the answer to this question will simply be 14. So if there are two functions, fx एक function है, gx एक function है, and there is a limit on fx plus gx, माने what can you do? You can separately put a limit on fx and separately put a limit on gx. The same is applicable to difference also. तो अगर fx minus gx है, put limit separately on fx, separately on gx and solve. जैसे यहाँ पर had this been a minus sign, तो हम माइनस कर देते, राइट? So you can also have these limits defined with a negative, with a subtraction also. अगर difference भी है तो भी ये limit defined है. Then beta product में भी limit can be defined in similar way. So if I have limit x tends to 2, x square log x, product है. So what will you do? You will apply it to x square. You will apply it to log 2, and then you will get the answer as 2 square ln 2. बस ये आंसर हो गया, right? So you can apply it to your product. You can apply it to any constant multiplication. So for example, if I tell you find limit x tends to 4, 4x. So this is equal to nothing but 4. Constant जो है उसको बाहर निकाल दो. It comes out limit x tends to 4x, and this will be 4 into 4. So this will be 16. So you also have a constant multiplication rule. इसमें हम बोलते हैं कि constant simply comes out of the limit. Then you have quotient rule, जिसमें आप numerator and denominator पे individual limits apply कर सकते हो. So in this case, if I go ahead and say limit x tends to 1, x square plus 4 upon x plus 3, ऐसा कुछ say. So you will simply apply separately to the numerator beta, x square plus 4. Simply apply separately to the denominator beta, x plus 3. So this is going to be 1 square plus 4 upon 1 plus 3. तो माने 5 plus 5 by 4. ये हो गया आपका limit of the quotient. Okay. Now, beta homework. Please try and solve these questions. These are based on product rule and quotient rule, etc. Homework. Homework. Try these, huh? Okay. Now, लिमिट में हमें बहुत सारे अलग अलग मेथड सीखने जरूरी हैं. बेटा ये तो बहुत ही बेसिक है. दिस इज कॉल्ड एज सब्स्टिट्यूशन मेथड. सब्स्टिट्यूशन मेथड सिंपली बोलता है कि जो भी आप x की वैल्यू आपको दी हुई है, सपोज इट सेज x टेंड्स टू -1, तो सिंपली -1 x की जगह हर जगह लगा दो. जस्ट पुट दैट वैल्यू एंड यू विल गेट द आंसर. So for example, let me take one from the homework. जैसे for example, this is saying limit x tends to 2, x plus 3 upon x plus 6. ठीक है, तो कुछ नहीं करना. Substitution method is simply saying just put x as 2 everywhere. So what will you get, बच्चे? You will get 2 plus 3 upon 2 plus 6. So this will nothing be, but this will be 5 by 8 and solve. So substitution method simply says कि आपको x की जगह पे जो भी लिमिट निकाल रहे हो, just put that value and you will get the answer to that question. That's it. Now, the second method, very important and very, very useful from exam point of view. Usually इससे एक question exam में आ जाता है. Sometimes you will see a question in the exam based on this. What this says, जो मैंने आपको शुरू में दिया था, that sometimes there is a discontinuity in the function. How do I know that there is discontinuity in the function? Sometimes it will happen that the denominator will become 0. So in such cases, जब आपका denominator ही 0 हो जाए, you can go ahead and you can apply the method of factoring. क्या method use कर सकते हैं बच्चे हम? Factoring method. जैसे for example, let me give you one more example here. So let's say you have x square minus 4x plus 4 upon x minus 2 and limit x tends to 2. Now just see here. जब आप x को 2 plug in करोगे, when you will plug in x as 2, what will you get? You will get 2 square minus 4 into 2 plus 4 upon 2 minus 2. तो clearly दिख रहा है that the denominator is 0. I can't even go further. The denominator is coming 0. I need to stop here. So one of the techniques that can be applied is a factoring method. ये हमें थोड़ा सा mathematically with practice it will hit us. कैसे? I can clearly see that this is the formula of, जैसे मैंने बनाया है बच्चे, this is the formula of a minus b whole square. A minus b whole square gives you a square plus b square minus 2ab. So if I had x minus 2 whole square, it will give me x square plus 4 minus 4x. So मेरे को clearly identify हो रहा है that this numerator that I have here now, this numerator is nothing but this is x minus 2 whole square upon x minus 2. So I can just cancel this out and I will be left up with x minus 2. तो यहां से हम बोल सकते हैं that limit x tends to 2, x minus 2, this will be 2 minus 2, which will be 0. तो फैक्टरिंग मेथड क्या बोलता है दैट यू कैन मेक फैक्टर्स एंड कैंसिल आउट. अब इसमें सिर्फ एक ही चीज है जो इंपॉर्टेंट है, वेरी इंपॉर्टेंट है रादर, दैट वी शुड बी क्लियर विथ सम फैक्टर्स. जैसे बेटा यू शुड बी क्लियर कि व्हाट इज द फॉर्मूला ऑफ a माइनस b होल क्यूब, राइट? व्हाट इज द फॉर्मूला ऑफ a स्क्वायर माइनस b स्क्वायर? व्हाट इज द फॉर्मूला ऑफ a प्लस b होल क्यूब, राइट? तो ये सारे फॉर्मूलाज, व्हाट इज द फॉर्मूला ऑफ a माइनस b होल स्क्वायर, a प्लस b होल स्क्वायर, ये सब हमें क्लियर होने चाहिए सो दैट द मोमेंट वी सी दैट वी विल बी एबल टू आइडेंटिफाई कि अच्छा 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 ये तो a माइनस b होल क्यूब का फॉर्मूला है, राइट? सो आई शुड बी क्लियर दैट दिस इज a क्यूब माइनस b क्यूब माइनस 3ab a माइनस b. तो अगर मुझे कुछ ऐसा एग्जाम में दिखे, सपोज मेरे को न्यूमरेटर में ये दिख रहा है x क्यूब माइनस 8 minus say 3 into 2 6x x minus 2, ऐसा कुछ दिख रहा है एग्जाम में. सो आई आइडेंटिफाई कि ओके ये जो न्यूमरेटर है ये तो a minus b whole cube ही है, where a is x and b is 2. तो I can clearly go ahead and quickly write this as x minus 2 whole cube upon x minus 2. ये बेसिक फैक्टरिंग है. वी शुड बी वेरी क्लियर विद दीज बेसिक फैक्टर्स, राइट? तो a माइनस बी होल क्यूब, a स्क्वायर माइनस बी स्क्वायर, a प्लस बी होल क्यूब, a माइनस बी होल स्क्वायर एंड a प्लस बी होल स्क्वायर. मेक अ फॉर्मूला शीट एंड उसमें ये ऑल 5 फॉर्मूलाज शुड बी वेल रिटन बाय यू. दिस इज योर फैक्टरिंग मेथड. हाँ, ओके बेटा, दिस इज योर होमवर्क. प्लीज ट्राई दिस होमवर्क क्वेश्चन. नाउ the next method, ye again very important from exam point of view, is called as the conjugate method. ये थोड़ा सा हम समझने की कोशिश करते हैं. What is a